Thanks for the invite, Anki, and thanks everyone in Brisbane for having me. I know it's pretty late, so I'm going to try and keep it as short as possible. I'm not going to go deep into demos. I just have code samples on my slides, so hopefully that'll help. My name is Kartik. I'm primarily an Android engineer, but I've been trying to understand AI not as a developer of AI, but rather a consumer of AI. And like Anki said, Gemini, which is Google's offering of an LLM, is a competitor for ChatGPT. And I haven't dived into what OpenAI has to offer from a developer's perspective, but I can talk about Gemini in general. So let's begin with that. What is generative AI basically? It's a branch of artificial intelligence that's all about creating content or data gathering, and not just recognizing or classifying it. Like having an AI that can be creative, but it produces images, text, music, whatever. You're not classifying things anymore, or even if you are classifying, you're using that information to generate more out of it. So generative AI, as it says. Generative AIs these days are a part of this larger um, thing called LLM. LLM is a large language model, which is a neural network that models the distribution of text on which it is trained. It's the current generation is mostly trained on text, but it can be trained on other things as well. And I'm going to touch base on that as well. It can take simple input like it's raining cats and then you can ask an LLM to complete that in a sentence. And then it'll go through its neural network to figure out what's the best thing that will go after it. And it'll have weights to each word and then try to complete the sentence. So if you think about it, a large language model is a very, very sophisticated autocomplete. Um, the autocomplete that we've had on our phones is a much smaller LLM. A model that is trained on poetry will predict an output that's poetic in nature. That's the nature of an LLM. If a model is trained on code samples, it will produce code as an output. And the current generation of LLMs are so large and trained on such diverse data sets representing all kinds of languages and context from around the web. These models have billions and trillions of parameters, so they can capture language structures and nuances much better than any other previous generation, much like a phone's autocomplete, but more complex. It makes one single LLM more useful for a lot of tasks instead of having five different dedicated models for five different tasks. If you've played around with ChatGPT or Gemini as the chat interface that offered for free, you would have recognized this by now that one single model is doing the work of five or six different models up until 5 years ago. Um, on top of this, LLMs let us prototype very, very fast using AI driven applications. This is huge because building an ML powered app or AI powered app would initially mean or traditionally mean that you collect a lot of information, then start the training, create a model, deploy that model, and then fine tune it for your use case. It wasn't easy. It couldn't be done overnight, unlike prototyping an app. So all of that, all of this condensed information, training, tuning has got us these LLMs, and you don't need to be an expert in ML anymore. Just use one of these LLM and build with them. You don't have to understand them. Thanks to their massive size, they are very, very good in understanding human language tasks like explaining humor. You can ask the model to explain things, or you can ask it to do something, and it will, in most cases, do that for you. Another example is just simulating creativity out of an LLM. It will get you started, and then you can deep dive into specific or just foray into something else altogether, and that same model will help you out. Now, why LLMs are different to traditional LLMs, uh, or LLMs in general are different to any other ML model for that matter. So LLMs these days have emergent abilities, which means They do not have to be explicitly trained to do things. They are trained on large data, but it learns how to translate, how to answer questions, code, and so on. LLMs change how we interact with intelligent systems because of their contextual understanding of human language. With an LLM, a simple SQL query or even a complex one becomes a simple question. You just have to ask. That's it. Um, Finally, LLM is the next generation in machine learning journey. Many years ago, you would find a simple regression pattern to filter things out, but with and then use neural networks, you will unlock hidden patterns in a data set. With LLMs, we can find those patterns and connections with other data sets, while those two data sets might not have anything in common. And you won't be able to see it in one go, but then LLM sees it and has been trained on it and can train itself further on it. And then with LLM, we have this concept of multimodality, which is very, very common with the current generation LLMs. Multimodality simply means can input, we can send the input in multiple forms. And it's important because you can provide a text, you can also provide an audio, and then you can also provide the image, all linking to the same question or the same query that we have. And then the context remains there because the signal is not lost. Um, as an example, an audio input and its transcription will ask the same question, but the audio ensures that the emotions in that text are not lost. So multimodality plays an important role to retain context. Coming to Gemini, Gemini models from Google are built up from ground up for multimodality. It's seamless across text, images, video, audio, and code. There are three Gemini model sizes these days. First one is the Ultra. It's the most capable and largest model. Then you have the Pro, which is good for scaling across a wide range of tasks. And then we've got the efficient one called Nano, which is mostly meant for on-device tasks and will be available through Android AI Core in the future. It is available on a few devices already, but it'll be available on a lot more going forward. Um, Considering the Gemini ecosystem from a consumer perspective or from a consuming Gemini perspective, we've got three different branches. Just for regular consumers, day-to-day usage, we've got the Gemini app, we've got Gemini in various Google products. For developers, we've got Gemini API, which is what we're going to talk about. And then for businesses and enterprises, you've got properly managed Gemini as an API on Google Cloud through things like Vertex AI or Gemini for Google Workspace. Like I said, this tech is mostly going to focus on Gemini API through the Google AI Studio. How do you get started with all of this? Uh, the aistudio.google.com, that's the platform you want to start with. It lets you create simple API keys for most tasks. It lets you create, test, and save prompts. It will also let you customize the models, fine tune them as you need. And then it lets you create starter code in many languages. Now, I'm just going to go through a few screenshots just to see how this is done. This is the AI Studio interface. It's a web interface, so you can take your ideas, quickly prototype without having to write any code. It's similar to the chatbot interface on gemini.google.com, except that it's got a few more things that a developer would need to work with with the AI. You can ask the model what you want to do in plain simple language, and then get results in a few seconds. And once you're ready, it'll help you move your prompt into your app and language of your choice. Um, First thing to start with is the API key, which is on the top left. Um, it's We all know what an API key is, so that's important to access the API. Then you can choose the model which you want to use for your task or your development. At this point of time, I think you've got the options of Gemini Pro 1, Gemini Pro 1.5 as a limited edition something, and then you've obviously got Gemini Pro Vision to work on. Also lets you add your prompts with multiple modalities. So in this case, in this example, you have text as well as three images. So the context of the question remains within these multiple modalities. And then once you're done, that button on the top right lets you get started with some starter code. Once you click that, you've got options across multiple languages: Perl, JavaScript, Python, Kotlin using Android, and Swift is just there on the example. But since the creation of Gemini Studio, we've got support for Flutter and Go as dedicated SDKs as well. So we've got SDKs for Python, JS, Swift, Java, Go, and Flutter. Uh, Beyond that, you can use a REST API. For this presentation, I'm mostly going to use the Python SDK for examples. But anything that is being covered here is possible through other SDKs as well as the REST API itself. Um, just to briefly talk about the Vertex API, that's the managed version, the cloud managed version of the same things that we're talking about today. The endpoints and the APIs are, I think, 1:1 they match. And Google is taking great care to make sure that they do not break the API from here to there. Um, it's just that the AI Studio is free. It's there to prototype and learn and fine tune things before you start paying on Vertex AI through Google Cloud. You obviously get the $300 credit if you're joining Google Cloud for the first time. However, it's a paid service, and you it's a managed service as well. The other thing to note is that AI Studio will and can use your input data to further train Gemini's model. Whereas on Vertex AI, they will explicitly tell you that none of your proprietary data or any of the data that you input will be used to train further. Um, yeah, that's the major difference that I've understood. I'm going to cover a few subtopics and usage patterns of using Gemini Studio or Gemini APIs in general. Some basic prompting, code generation, search information synthesis and retrieval, function calling, image understanding, and fine tuning of the model itself. Um, let's start with simple text prompting. Uh, you can at AI Studio, you can simply just ask write a poem about a magic backpack, and model will happily give you a poem with many verses, rhymes, etc. The example was quite long, so I've truncated it here, but you get the idea. This makes a nice example, but in practice, you're unlikely to do something this simple using your project. Uh, let's imagine something else that you run a JavaScript daily tip newsletter, um, but you're running short of examples. So you can ask Gemini to start generating tips for you, and you can use that and put them in your newsletter and do your task. Or you can use this further to build an API within your newsletter software so that it generates it automatically and sends it over. So this prompt will give you something like this. This is just an example. Your experience will vary because it's a generative AI, so it's going to generate content based on different settings. Um, but there's an issue with this kind of prompting where if you start typing the same prompt again and again and again, your chances of getting the same results increase. So you can request some diversity and creativity through model settings, things like temperature and number of outputs. But there's a better way if you want very, very unique outputs. Um, and this is called a few shot prompting. Um, what we do over here is give the prompt an example of what we want. So the topic and tip is the example. And then at the end, we give another topic and then just leave it at the tip. We leave the prompt hanging at the end so that the model will continue at exactly same point and it generates the tip itself. Um, in this example, this is a one-shot prompt because we only have one example. But once you give multiple examples, 4 to 5, it generalizes into a few shot prompting. And once you run this on AI Studio, we get a structured prompt because the prompt itself becomes a table with examples. And then every time it'll give you something in response, which is similar to your provided structure. In this example, I think it's going to only generate one example, but you can ask in your prompt to give you 100 different tips, and you'll have a lot of content to play with then. Now, let's see how this would look in Python when you're using the API itself. So Google has published their Python package, and this is how you import. Basically, you create a model object using the model/Gemini Pro object, and then you ask the model to generate content. And that's the same prompt that I showed you a few slides back. And in the output, you can just do response.text to get the output of generated content. The other way is the chat interface. Chat has a conversational state. If you're making raw API calls, you need to manage that yourself. But with the SDK, the state is managed for you. Um, this also means that it keeps a history of that chat, and it also lets you play around with different things within that chat itself. And I'm going to talk about it in a few slides again. Okay, moving on. There's a lot of depth and nuance in prompt design itself. It's so vast that it could be a content or a talk in itself. So I'm not going to dive deeper into that. Google has published this document, which you can read if you want, for prompt best practices on Gemini. As a simple example, your chain prompts should be divided in such a way that each prompt does something simple, something atomic, and then the next prompt builds on top of that, and then so on and so forth. Um, Giving your prompt as much context as possible is helpful so that it understands context better and then generates content on top of it. There are a few parameters that you tweak. There are things like temperature, safety settings. There are parameters called top K and top P, which I don't understand because I'm not a AI developer. Uh, but this guide will be able to explain things better, and modifying these will give you different kinds of results within the same prompt. Right, let's jump into code generation. On top of text generation is code generation. The concepts are the same. The usage is pretty much the same, where you can specifically request for code or scripts as output. Simple example is we can generate data using Gemini. Something as simple as asking it to generate 3 columns and some sorting within that. Then we can further ask, and this is where we are breaking or chaining our prompts. We can further ask Gemini to build an SQL query out of it for us. We asked it in a very plain, simple to understand English, and it gives us a SQL query back. Now, we can also ask the model to simulate the execution of this SQL query. Now, we did that. It gives us a simulated output. Now, this isn't backed by a real SQL engine or even real data. This is all generated. So you can expect the output to be somewhat speculative or incorrect, but that's it. That's okay because we're getting started with how to use that particular prompt or how to fine tune that prompt in order to get our work done. We're not using this as fact. We can also use Gemini Studio or the Gemini API as a pair programmer. Uh, in this example, I'm not an expert or even remotely close to Docker or Dockerfile syntax. So instead of me figuring out or spending hours on Google to figure out how to write Dockerfile syntax, I can just ask it to help me do that and generates something basic which I can use. And obviously, before I use it, I will have to make sure that it's right and it's not hallucinating. It can also help us generate unit tests. And using a basic example over here, this is a basic Python function. Let's not worry about if it is factually correct or not, because we just want to make sure that we are unit testing it. So if we give this function, so if we run this prompt in Gemini, this is the output we get. this is one of the outputs we get. This is the output I got. So it does some input checks. It does type checks. So basically, it does things that you would do anyway. But you've saved some time. You can copy paste it and then improve the code over there. You're using a very basic, very vague prompt here. Um, you can add as many specific instructions as you need. Like you can ask it to try, for example, 50 different inputs, and then it'll do it for you. Jumping into searching information synthesis and retrieval of that information. Um, a common question when starting or using LLMs is how do we get our own data into that LLM and then use it? Um, it's important to understand that all LLM models have knowledge cutoff dates. They were trained at up until a certain point, and then they do not know anything after that. Um, because of that, they are very limited in their ability to reliably produce facts, and ultimately, uh, they'll just say, "I don't know what you're talking about," because that thing happened in the future, but the LLM was not trained for it. So you think of it as a machine which stopped growing after a day. Um, to deal with this, we can provide some information to Gemini's model itself, and this will lead us up to fine tuning. But there are ways to provide data without fine tuning the LLM. Fine tuning is a very complicated, well, not complicated, but it's a resource intensive task. So Gemini makes it possible for us. We can provide contextual information like we've seen so far. It's also called stuff prompting because we're prompting with more stuff for the information. But then there's other ways as well. And this is specific to Gemini as far as I know. Uh, in this example, we're taking a TXT document and we're providing a prompt which takes a question as well as provides the document as well. So we're requesting the model to, please base your answer based on the following document. And Gemini is quite powerful. It will consider your document as the source of truth. As an example, if my document says deep sea life doesn't survive, it is mostly dead, and then I ask this question, explain how deep sea life survives, it will give me a statement similar to this, that the document says it doesn't survive, so it's mostly dead. Therefore, I cannot provide an explanation. It will not consider the rest of the information that it already has. If I were to remove the document from that prompt completely, it'll use its own information to answer that, which may or may not be factually correct. However, if I provide this in the document where this is a statement literally copy pasted from my Google search, so hopefully it is factually correct. I'm not an expert. So if this is the basis of the answer, then this is the answer that I got back. So your response might vary when you try it, but it'll be somewhat similar. Now it's important to understand the context window of a model. Gemini 1 Pro is limited to 30K tokens. Now, how does a token translate to characters and images and everything? That will all be listed on Gemini's documentation. Whereas Gemini 1.5 Pro, which is still not widely available, it'll be there soon. It has 1 million tokens, so it has the capability of handling much bigger problems. Gemini 1 Pro is still limited to a small problems. So yeah, Gemini 1.5 Pro, everything is tokens. Every input that you give is a token. Uh, it's important again to remember that the more input you give, the higher would be the latency because then it has to process all of those tokens before it can generate an output. You can join the waitlist to get access to it. I'm not sure on what basis they're providing access, but this is the resource if you wanna consider it. Next up in bringing your own data is function calling. Now, so far we've taken the document and given it to Gemini to provide an answer. With function calling, we're kind of doing a dance over here. We ask We tell Gemini that we have this function which takes X and Y and Z parameters, but we're not going to tell you what the function does internally. So we hide that. And then, yeah, um, the model will ask you or your program to execute that function and respond to the model back. And then it'll use that result to create its result. Um, so yeah, think of it as question answer until you arrive on your final answer from Gemini. Um, this is super useful if you have proprietary code which you do not obviously want Gemini or the world to see because then it might leak. So you just tell Gemini, I have the function. Don't worry about its execution. Don't worry about what it does internally. Just whenever you need to, this is the signature of the function. Please call it. Um, some things to remember for function calling is that uh, there's a schema to it. You can't just provide any function. There's a certain schema to it, and all of that information is available on that link. And then there are limited types allowed at the moment. This could expand in the future, but for now, it's integers, floats, strings, booleans, lists, and dictionaries in Python, and similar types in other languages. There's this thing called automatic function calling, where the model will basically be granted a permission to call the function on its own. Otherwise, it's like the model asks you, you provide yes or no as an answer, and then it executes the function. For simple tasks, if you just enable automatic function calling, it makes things easy. And I'm going to I'll make this example very, very basic and simple, uh, just for the understanding's sake. I've created this function called multiplier, which literally multiplies. Um, Important thing to note is that the model itself knows how to multiply, obviously, but in this case, we're going to override its information and tell that uh, when we consider the function multiply, it returns the multiplication of two numbers, which are these parameters a and b. So it would prefer using this multiply when it wants to multiply over its own understanding of multiplication. Um, you don't have to call this function directly or even tell the model to call this function. Just the context is enough. For example, we've enabled automatic function calling here. So when you ask a question like this, that you have 57 cats and each has 44 mittens, how many mittens is that in total? So Gemini is smart enough to understand that, okay, I probably need to multiply 57 and 44 to get the answer. But then because we've provided a tool, um, the model will prefer using that because that's your truth now, and then get the result back. So once all of this executes, we get this result. The number of mittens in total is 2508. Now the 2508 part is what our function returned. The rest of the text is generated by Gemini. But let's backtrack a little and understand what really happened in this conversation with Gemini. Um, like I said earlier, there's a chat within the chat kind of conversation. There's chat history. Now, chat history contains objects such as role and part. Role uh, basically says what was the who was responsible for that content, and then the part itself is the content. So if we use chat history and write a function or a for loop like this, um, we'll get an output of who said what and what was being said. Something like this. The user said, I have X cats and which own 44 mittens. That was the prompt. The model then responds with a function call, which is the type of that particular response. It's not an output in itself, or at least not a visible output for the end user. It's a function call output, which basically tells our code or my Python code in this case that I am requesting you to call the multiply function with arguments 57.0 and 44.0. Now, the user or my function will then execute that function locally and then send the response back to Gemini saying the answer is 2508. And then the model responds with a text saying the number of mittens is 2508. You can see the multimodality over here as well. There's text as a modality, there's function call modality, there's function response modality, and then there's text modality again. But to the end user, you only see the two text modality, but all of this exchange of information to and fro is happening behind the scenes. As another example, I don't have a lot of code for this, but just as another example, if you imagine a function which does a Wikipedia search based on a list of queries and then responds with a list of results, you can tell the Gemini model that this is the function I have. You enable automatic function calling, and then you ask, we'll start with one query, explain how deep sea life survives. And if you were to do the chat history thing again, it'll go through a few things where it will actually search and then print things out. We'll get a lot of information. A lot of this information will go back to Gemini, and then it will eventually give us a result back. Now, this is a bit more complex example of function calling, much more complex than multiplication of two numbers. But I suppose now you can imagine how this can be a complicated way or easy way to call complicated functions which you do not want to share with the world. Next step in the multimodality part is understanding images. In the next few slides, I have a few images which you might or might not have seen before. So if you do know the answers to that, or if you've seen that before and you know the answers, it's great. Otherwise, I'd like other people to participate in my questions going forward. So yeah, this image was provided to Gemini. Before I reveal the answer from Gemini, I can't really see people over there. I hope everyone can hear me. I hope I can hear as well. But what do you think is the name of this movie? I can't really hear. Anki, can you help?
Sorry, Chocolate Factory? Charlie and the
Chocolate. Yeah, that's correct. Charlie and the Chocolate Factory. Now, this was simple. We just asked Gemini to guess the movie. We can ask, guess the name of the movie and explain your reasoning. But before I move forward, any guesses?
Home Alone.
Yeah, humans are much smarter than LLM these days. Obviously, the movie is Home Alone. But with our second section of our prompt, explain your reasoning, Gemini gives us its reasoning. It offers insight, and Gemini is great at offering its own insight, even if it's wrong. It does have some cultural understanding of the world. It knows some facts. It's not a fact generating engine, but it knows facts. That's why it was able to guess with house and that iconic face emoji and Christmas tree that, okay, maybe this is Home Alone. Any guesses on this one? This time it's a book.
Secret Garden, maybe.
Yep, it's The Secret Garden. That's right. This time we did not ask Gemini to explain its reasoning. Next one, anyone? This should be easy or hard, depending on how deeply you follow pop fiction. If anyone's guessing, I can't really hear. I can't really hear, so I'm just going to reveal the answer. The answer is 2001: A Space Odyssey, because there was monkeys, there was a monolith, and then there was space in that movie, and that's all Gemini needed to be able to guess that movie. Okay, this was just basic interpretation of image. It can also understand text and images within an image. So this entire thing is an image which has some rasterized text in it and some more images inside it. And we've asked it to explain it step by step, and it does that. Uh, Now, I haven't sat down and checked if the answer is correct, but at least it's able to understand a simple math problem. It's able to convert that image into a basic uh, algebra problem and then solve it for us. So all of this was done on the Gemini Studio, uh, Gemini Studio platform, but all of this can be done in the SDK, which means you can take all of that, put it in your software, and hide it from the end user and make your own app much, much smarter. Um, it's quite capable of understanding contents of images. The positional part of the model input, interleave with text prompts, adds some context, adds layers of context, and then Gemini understands them. Now, images are just tokens of the input, so we have to be careful about the number of tokens available. Um, the images can be used for instructions, context, or just for a further query. In this case, this was a query as well as context. There's a separate model from Gemini called Gemini Pro Vision, which is also available and for free in Gemini AI Studio. And then it's trained one step beyond regular Gemini Pro because now it understands images and has the capability of taking images in. Um, so yeah, if you're not using Gemini Pro Vision and then provide some images, it will give you error messages back, or you'll get some sort of wrong answer. I haven't tried it, so I'm not sure. Now let's see how we can use this in Python using the SDK. So this is an image called instrument.jpg that Google has provided for demos. I'm just using the regular pillow library to open the image and then show a small 200 by 200 thumbnail of it. And then we use this kind of syntax where we layer the prompt in a list this time. So what instrument this is, the image object itself from pillow, and then what kind of music would use this particular image. So we've seen this image. It might be a little small here, but for your understanding, it's a pipe organ. Now we call this function and we get a response. This is a pipe organ. Organs are used in all kinds of music, blah, 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 blah. So it gives you the answer exactly as you want. It gives you a single chunk of text. I'm just going to deviate a little bit. There are options or ways to get chunks of response or different modalities of responses. But I'm not going to cover that in this presentation. In this case, we've gotten the entire answer in one go. So image understanding gives us two further contexts over here. We can use images for conditioning of our prompts, or we can use images for structured data extraction. With the JS prompt that we created earlier to be able to get a new tip every time, it was called conditioning because we're conditioning the prompt in such a way that we end up getting a new tip every time. Now, you can use an image to condition that particular prompt. The prompt over here is write a character statistic sheet based on this character, which if you've played RPGs earlier, you might be familiar with. If not, you're basically creating a character for a game. Not necessarily a game on computer, but a role-playing game which is played in person. Now, we've given a conditioning image where we have drawn something very rough. It doesn't have to be perfect. And then Gemini uses that conditioning to give us a response and kind of gives us some information as to what this character could be. Now, you can use that as it is, or you can use and modify it, but then it saves you some time to start thinking about things. You have a starting point, you can go crazy with it. And this is the minimum boost that you need for creativity. The next thing is structured data extraction. Now, this is a form which has both printed characters as well as handwritten characters. And Gemini is smart enough, if you asked it to convert it to JSON, and it will capture all of that details and give you a structured JSON. Now, in this case, it has just given you some format or some schema of JSON. But if you start doing a one shot, few shot prompting in this case, which is text based conditioning, you can ask it to give you a particular structure as well. And Gemini is great at that. Gemini is great at understanding code that way. All right, I'm going to jump into the last part of the whole Gemini SDK thing. How to fine tune a model. Now, fine tuning is available through Google AI Studio, and it is also available through the API and the SDKs. A quick run through of how to do it on AI Studio. There's a section on the left which lets you click on new tune model. You can select a base model, or you can create a structured prompt of test data, or you could import a sheet from Google Sheets. That also works. Once you have your columns and data and everything, it would look something like this. This is just sample data. What we're trying to train here is whenever a number is input, the model should return an incremented number. So 1 returns 2, 3 returns 4. That's the training data we're training on. And then you select the model. You have a few more advanced settings, which I don't understand, so I just leave them be. I'm sure AI developers would understand what they are. And then we hit tune. It gives you a nice progress bar of what's going on, how much time it's going to take, learning rate, things like that. And now you just wait for it to complete, and then you can use it the way you've been using it so far. But this time, your own tuned AI, well, your own tuned model in this case. Now, it's possible to tune in the API as well. It's not very different. It's very, very similar for that matter. However, because now you are providing your own complex data, it's not that straightforward. You'd still need to, you need to set up an OAuth app and provide some credentials to the process itself, so that whoever is providing that data and running that particular application needs to authorize that yes, this application has access to my data. So it's your API key is not enough for tuning. I'm not going to go through the OAuth setup because that's very similar to how you set up OAuth in a GCP project. It's just a different scope. But yeah, it's possible. The permission handling is not part of the SDK yet, so that has to be done separately. But once that permission has been granted, you can use the tokens, the new authorized tokens, and the credential file to run your particular software. All right. In Python, we will get a base model, and not every model out there has the capability of creating a fine-tuned model. So using this for and if syntax in Python, we get the list of models which have create tuned model capability. And then in this example, I've literally taken the first one that's available, and that becomes my base model. And I'm just going to call it generate num plus 1, 1, 2, 3, 4. It's a name, but it's more like a unique ID. So next time I want to create another trained model, it's not good. It can't be called 1, 2, 3, 4. I can call it something else. In this training data, I've got about 20, 25 examples of text input and output. It's all there on my GitHub repository. I'll share the links later. And so the training data also includes words apart from numbers. So literally the word 0, 1, O, N, E, and the output should be TWO. All of that is there. And then we basically just send the request to Gen AI to create a tuned model. Now, this will send a request to the API. And then if you're logged in with the same account you've used to authorize Gen AI over here, you will be able to see the training happening over there. Or you can use you can try and get the tuned model over here and get its state. Now, any tuned model that you create on AI Studio is prefixed with tuned model / whatever name or ID you gave it. It's as easy as fetching your model like that. If you've noticed, you get an operation object back when you call create tuned model. You can use that operation to get a wait bar and then keep on waiting until that wait bar is over. That wait bar basically tells you that the operation is still going on, please wait for it. And then it also prints a status bar on the console of when you're running Python. And then there are multiple states. This active state basically tells that this model has been tuned and is ready for use. Now, once that model is ready, we can run inference with this model. And then because we tuned it for one intended task, that is increment the input, it does that beautifully. I've entered the input as 55. It outputs 56. Um, in the next few slides, you'll sort of understand the power of LLM in understanding the context of training data. And please note, we've only used a single modality training data, that is text. And from text itself, it can understand a lot of context. So you can imagine how much powerful it becomes when you've got a multimodality training data or input. Asked it a question in French, and it responded in French. So it understands what I'm asking for without me having to, write a full sentence. And if you go and check the JSON file later on, it only has English words or English characters in it. It understands Roman numerals. It also understands Japanese characters. Take my word for it, these two Japanese characters are correct. I don't understand Japanese, but I've checked it multiple times that yes, this trained model is returning me the right answer. But yeah, my training data had nothing in French or Roman or Japanese. And my questions over here, my prompts over here was simply as simple as the number as input. But Gemini was smart enough to understand what I might be doing. It is fine tuned in doing this, and it is able to give me the result. That concludes the tuning part of it. And before I close, this is something important and something that I personally believe in, which is responsible AI and responsible use of AI. Models are powerful, as we've seen so far, but then we also have to make sure that the outputs are not being used in wrong context. We have to make sure that the output is being safe. As developers, we are responsible for anything that AI generates. So it's our duty to fact check these things and make sure we're not providing mass hysteria, right? Um, so Google has published a few guidelines for safe AI usage, and then the Gemini API itself comes with a lot of built-in safety filters. As developers, you're able to change these, but be very cautious. If you do not understand these things completely, ask somebody who does or get help from somebody who does. I personally don't, so I haven't modified any of these parameters. However, going forward, if I am working with AI, I will make sure somebody who understands AI is helping me around it, and I'm only using it as a developer, not as a AI expert. That being said, ai.google.dev is your playground. There's a massive Discord community for all things Gemini, where you can chat with other developers using Gemini and the team which developed Gemini itself. Thank you for listening. It was a good 50-minute talk, and I'm open for question and answers.
Yes, any questions?
Just one.
Sorry.
Yeah. So you were talking about calling functions via Gemini model in Fast code. So I was just curious, where does that function run? And if that function requires some sort of specific environment, would Gemini know about it?
Okay, yeah, that's a very, very good question. As far as I understand, because Gemini is asking the program or sending the information to the calling program that this is a function called response, please execute that function. That function will be called in the local environment of where that program is being executed. Now, that could be your computer if you're developing it. It could be on a server if it's a server-side code. It could be on the app if it's using the Swift or the Android SDKs. The context of that function being executed is local. Once that executes, you get the result, and that gets sent back to Gemini, and then it does what it needs to do with that answer. I hope that helps.
Yeah. Thank you.
Any other questions?
Not a question, actually, not like curiosity of, do you know if anyone has experimented with providing the same prompt by a group of people in the same network or different time zones? And has there been any variation in the responses from Gemini?
Sorry, I didn't get your question. Your voice was cutting off.
It's more like, I was just curious to know if Gemini provides the same response to a group of people in different time zones or different places, but they have the same exact prompt. Has that been experimented or anything? Just curious to know.
Oh, that's really interesting. Honestly, I have not experienced it or even thought about this. But yeah, it's an interesting question that you asked. I am not a Gemini AI expert, so I wouldn't know the answer to that. However, I kind of feel like doing that experiment now, so I might just do it one day and publish it on my blog.
Looking forward to it.
Thanks.
Gemini doesn't really have any context of what time zone it's in.
But I was just thinking,
If your question had a location-based bent to it, it might get a. But from you're submitting it to an engine which is running somewhere.
Yeah.
It's not really context aware of the time unless you say, imagine you're in south of France on the 27th of May. What happened with blah? Because it's just processing the information that you feed it. It doesn't go, oh, I'm in South Carolina.
Yeah, that was my thought process as well, that it should not matter if somebody's sitting in San Francisco or Sydney or Brisbane. They should get very similar results, just worded differently, maybe paraphrased from one to another. But then as you prompt more, you'll see that same pattern of response keeps repeating, irrespective of where you are. But then I can't confirm it without having tried it.
Any other questions? No, okay, yeah. Thanks, Kartik. I think it's very comprehensive. I think it talks about more about Gemini API, but then in the workshop we will do a bit like more demonstrations on AI capabilities. And also there is a workshop, and also there is like some training tutorials as well. So yeah, welcome to the workshop. So for now, yeah, let's thank Kartik for his talk.
Thanks, everyone. Just one last thing. If you scan this QR code and go to the talks section of my website, I've already published this presentation and the code for this presentation, the entire Python code. Just feel free to clone it or copy it, and just add your API key and get started and play around with it. Thanks, everyone.